first derivative test is a way to determine intervals where a function is increasing or decreasing. We can use the first derivative test also to find relative extrema on a function. Let's remember that word relative extrema. Relative means just within its area, is there a maximum or a minimum? So first off, we know that if f prime of x is greater than 0, that means that the derivative is positive or the slope is positive, slopes of tangent lines. So if a slope of a tangent line is positive, that means that your function is moving up or increasing, which means that if f is decreasing, f prime of x would be less than 0, would be negative. Okay, what about if f is constant? If f is constant, that means it goes straight across, which means that the slope is 0, which would be f prime of x equals 0. Alrighty. Steps for finding increasing and decreasing and constant. So the first thing is finding critical numbers. Critical numbers happen where f prime of x equals 0 or where f prime is undefined. And if we have a closed interval, we also have to test endpoints and see what's going on there. Number 2, write the intervals between those critical numbers. So from where to where, from what x value to what x value. We'll substitute a value from each interval into f prime of x to test it. That's where we just pick a number in the interval, so between your two endpoints, and see if f prime of x is positive or negative. We don't care about the number, we just care about positive, negative, or 0. It's not going to be 0. Indicate how the function behaves from the rules above. So let's take a look at this example. We're going to find the open intervals. Open means parentheses, on which f of x equals this cubic function is increasing or decreasing, and we do have a picture. So we should be able to see based on the picture that from negative infinity to x equals 0, our function is increasing. Then from 0 to, looks like 1, our function is decreasing. And then from 1 to infinity, our function is increasing. That's how we learned it back in like maybe algebra 1, maybe algebra 2, kind of depends on which topics you covered, but we had increasing, decreasing, and increasing. Our job is to use calculus to find the spots where the mins and maxes are, or where something weird happens, because you know there's also spots where, like for some cubic functions, we are increasing, and then for a second we're just like stuck there, and then we're increasing again. So those are potentials, and we have to look out for those spots right there. So how can we find mins and maxes? We find critical numbers first off. We find critical numbers by taking a derivative and setting it equal to 0. So f prime of x equals x cubed is 3x squared minus 2 times negative 3 over 2 is negative 3, x to the first power. We'll set this equal to 0, so replace f prime of x with 0, 3x squared minus 3x. And you can use the quadratic formula because it's a quadratic, or you can factor. Most of the time you should be able to factor and set each factor equal to 0. So 0 equals 3x times x minus 1. Set each factor equal to 0. Divide by 3 and get x equals 0. Add 1 and get x equals 1. And you can see over here that yes, x equals 0. We had a slope of 0 for our tangent line. X equals 1 right there. Slope of 0 for the tangent line. So we're doing this right. Yay. Most of the time, they won't give you a graph. You'll just be given the equation, and you'll have to find all of this stuff calculus-wise, not like plug this into your calculator and find mins and maxes using graphing calculator like features. Okay. What we're going to do next is we are going to create what is called a sign chart. And I believe we've seen these before. we're going to have the number 0 and the number 1. Sometimes you will put arrows on the ends, sometimes you'll put endpoints. Since we did not have any limits for our interval, like our domain is negative infinity to positive infinity, we can put arrows. Okay, so these are x values. And we're going to figure out f prime of x values. We know that at 0, f prime of x is 0. At 1, x equals 1, f prime of x is 0. So f prime of 0 is 0, f prime of 1 is 0 as well. We're going to pick a number in each one of these intervals. So to the left of 0, maybe like negative 1. X equals negative 1. So we're going to test out f prime of negative 1. Between 0 and 1, there's not any really good options, so let's just use a half. And then to the right, let's pick x equals 2. You can pick literally anything to the right of 1. Okay, so up here on top, we're going to find the sign of f prime of negative 1. We're going to find the sign of 1/2, and we're going to find the sign, of f prime of 2. So all these signs are of f prime. Okay. We can find the signs of f prime by plugging into our original, into f prime of x. So we're going to plug in negative 1, 1/2, and 2 into this right here. F prime of negative 1, f prime of 1/2, and f prime of 2. You guys know how to plug into an equation. If we look on here, we can see that at negative 1, we had a positive slope. At 1/2, we have a negative slope. And at 2, we have a positive slope. So we know that those f primes are positive, negative, and positive. So we're going to put a plus here, a minus here, and a plus here. This is called the sign chart. Because of the signs of f prime. We will use this again with the second derivative in a future lesson with f double prime. That's going to tell us other things, not increasing and decreasing. So we know because f prime is positive here and here in those intervals, f is increasing on the interval negative infinity to 0 in union with the interval from 1 to infinity because f prime of x is greater than 0. Remember that you have to say where this is happening and why. And then f is decreasing on the interval from 0 to 1 because f prime of x was less than 0. And so this is our answer, including a reason. Back, the first derivative test. C is called a critical number of a function. F is the function, and f is continuous on an open interval I containing C. So I is just like from 3 to 7, or from negative infinity to positive infinity. They often use the letter I to indicate an interval. It's not really special, it's just an interval. C has to be between the left and the right endpoints if there are any endpoints on your interval. Okay, if f is differentiable on the interval, except possibly at C, then f of c can be classified as follows. Okay. What this means, if f is differentiable on the interval except possibly at c. So we can look at specific little spots, and c is one of the numbers that's in between. C would be 2 in this case. Except possibly at c means that it's possible for us to have a non-differentiable function at that very specific X value. So we can have a corner or a cusp specifically at C. Just gonna draw them, corner or cusp at C, but not at any other spots. Okay. So if F prime changes from negative to positive at C, then F has a relative minimum at C. And if F prime changes from positive to negative, then F has a relative maximum at C, F of C, right? X value, Y value. Number 3, if F prime is positive on both sides of C or negative on both sides of C, then F of C is neither a relative maximum nor a relative minimum. Okay. Alrighty, let's take a look at the examples, and I'll refer back to 1, 2, and 3 up above. Okay. The first example, we have a relative minimum here. It is at the point 2, 1. So the relative minimum is 1, and it happens at x equals 2. Take a look to the left side of it. This is a decreasing function from negative infinity until x equals 2, because f prime of x is negative, right? Any tangent line that we would draw, we would have a negative slope for that tangent. Our function is decreasing. On the right-hand side, any tangent lines we would draw over here would be positive. So f prime of x is greater than 0. So it switches from negative slopes to positive slopes. So this is a relative minimum. Over here, this spot right here is a relative maximum at 2, 1. It's a maximum because we switch from increasing to decreasing, right? Our function is moving upward and then it is moving downward. Increasing function means that f prime of x is greater than 0 or positive. Decreasing means that f prime of x is less than 0 or negative. Okay. So this first one represents number 1 from up above for the first derivative test, and this one, since it's a relative maximum, is number 2. Okay. Let's look at the third and the fourth. Let's focus on this guy right here. At this spot, we have a horizontal tangent line. The slope, meaning f prime of 2, is going to equal 0 at that very specific spot. But our function to the left was increasing, so f prime was positive, right? Increasing. Over here, our function is still increasing. F prime of x is greater than 0. So there's no switch in sign between the left side and the right side. So this point 2, I'm going to say that's 1 again, is not a relative max or min. Okay, which that should make sense. Like, it's the maximum of the left-hand side, it's the minimum of the right-hand side, but we need an open interval to figure out relative maxes and mins. All right, over here. Same kind of deal here at 2. Let's call it 2, 1 again. 2, 1 is not a relative max or min. Not a relative max or min. Because to the left, our function is decreasing, which means that f prime of x was less than 0. And to the right, decreasing again, f prime of x less than 0. So negative slopes, so this cannot be a relative max or a min. So you're probably thinking, Ms. Campbell, I can see right here that is definitely not a max or a min. Why do we have to go through this effort? And it's because in the examples below, we have to find relative extrema and increasing and decreasing intervals without using a graph. Okay, so we're using just the equations to help us figure that out. Okay, we can use sign charts as well. Let's take a look at this example. Find the relative extrema and the increasing, decreasing intervals of f of x equals this function. We have this interval from 0 to 2 pi. That's important because sine of x continues on forever in that fun curve. In order to figure out relative extrema and increasing and decreasing, we need the derivative. So let's take the derivative. F prime of x equals 1/2 minus the cosine of x. We find critical numbers by setting this equal to 0. 0 equals 1/2 minus cosine x. And then we need to get cosine by itself and figure out where cosine equals whatever. So we're going to add cosine to both sides. Cosine x equals positive 1/2. Where on 0 to 2 pi does cosine equal positive 1/2? This happens at x equals pi over 3 and 5 pi over 3. All right, use your unit circle to find the spots where cosine of x equals 1/2, and these are them. So these are the only spots where relative extrema could occur. We could also have relative extrema at endpoints. So we have to check endpoints and any critical numbers. CN for critical numbers, or CV sometimes for critical value. Okay, let's make a sign chart. This time on our sign chart, we do not have arrows, and that's because we have endpoints at 0 and 2 pi. These are x values. We also have x values pi over 3 and 5 pi over 3. Okay, we know that f prime of pi over 3 equals 0. F prime of 5 pi over 3 also equals 0. That was this whole bit, right? We set it equal to 0 and then solved. We don't know f prime at these two values, nor do we care. Okay, we just care about in between in the intervals. So we need a number that's in between 0 and pi over 3, like, I don't know, maybe pi over 2. So let's take a look at pi over 2. In between pi over 3 and 5 pi over 3 is just pi. That's an easy one. And then in between 5 pi over 3 and 2 pi is like 11 pi over 6. Again, use your unit circle to find like what's in between these. 11 pi over 6. Hang on a second. I think I said pi over 6 and then wrote a 2. Pi over 2 is definitely not between 0 and pi over 3. So fix that. All right. Pi over 6. If we plug in pi over 6 into our derivative, because remember, we're trying to find what are the signs of the slope. Okay, so we got 1/2 minus the cosine of 1 pi over 6. That is a negative number. Plug in pi. Cosine of pi is 0, so we're left with 1/2 minus 0 is 1/2, which is positive. And then between 5 pi over 3 and 2 pi, we have 11 pi over 6. That's a smaller number than 1/2, so this is a negative number as well. Okay, so use your unit circle, do 1/2 minus whatever that number is. We get a negative number here. Okay, so our slopes are all negative, and then 0, and then positive, and then 0, and then negative again. So our graph looks something like this. Our graph of f of x is decreasing. Then we reach a minimum at pi over 3, and then our function is increasing, and then we reach a maximum, and then our function is decreasing again. Okay, I don't know how tall these spots are. But I know that right here there is a minimum And right here, there is a maximum. And we have a decreasing function, increasing function, decreasing function. Decreasing because derivatives were negative, increasing because derivative was positive. Minimum because our function went from decreasing to increasing. Maximum because our function went from increasing to decreasing. Okay, so let's write that out. We have an increasing function. So f is increasing on the intervals from 0 to, increasing here. That was pi over 3 to 5 pi over 3 because f prime of x was positive. F is decreasing on 0 to pi over 3 in union with 5 pi over 3 to 2 pi because f prime of x was less than 0. So that because portions are very, very quick, it's just f prime of x is greater or less than 0. We have a relative max at x equals 5 pi over 3. And that relative max is because f prime of x switched from positive to negative. And there's a relative min, kind of ran out of room, relative min at x equals pi over 3 because f prime switched from negative to positive. So same kind of deal, just switch out those for pi over 3, negative, positive, and minimum. All right, next one. Find the relative extrema and increasing, decreasing intervals of this function. Okay, this one is a lot less pretty. However, we can do some rewriting so we don't have to use the quotient rule. Let's rewrite this as x to the 4th over x squared plus 1 over x squared, right? If we only have one term in the denominator, we can rewrite two separate fractions with the same denominator. That is the same thing as x squared plus x to the negative 2. And we're going to take a derivative. So f prime of x equals 2x minus 2x to the negative 3. So 0 equals 2x minus 2 over x cubed, right? Move that down to the bottom. Okay, then on this, we are going to, add 2 over x to the 3rd power to both sides. So we get 2 over x cubed equals 2x. We want all the x's not in denominators. So 2 equals, multiply 2x to the 4th power, and then divide by 2, 1 equals x to the 4th. X would equal positive or negative 1. Also at x equals 0, f prime of x, you can't do it because you can't divide by 0 over here. All right, so we're going to make a sign chart that includes 0, -1, +1, and we're going to go from negative infinity to positive infinity. So sign charts. -1, 0, 1, 0, 0, undefined. We are going to plug into f prime of x. Pick a number that is less than -1, like -2. F prime of x is negative there. Pick a number between -1 and 0, such as -1/2. and the derivative is positive there. Between 1 and 2, we've got 1/2, which is negative when you plug into f prime. And then from 1 to infinity, let's plug in 2. You get a positive derivative there. Okay, so based on this, our graph is decreasing, increasing, undefined, and then decreasing, increasing. Okay, so here we can see from f of x from the very beginning that if the denominator is 0, like if x is 0, the denominator is 0, so our graph is undefined at that spot, which means that our graph is not continuous right there. Okay, let's do increasing and decreasing. Increasing from -1 to 0 and from 1 to infinity. -1 to 0, 1 to infinity. Decreasing from -infinity to -1 and 0 to 1. Technically, there's some spots where you should be using brackets, but the AP exam kind of lets that slide and you just get to use parentheses. Then our goal is to figure out relative maxes and mins. Relative mins happen where your slope changes from negative to positive, right? Graph's got to do something like this. That's going to happen here, negative slope to positive slope. It also happens over here, negative slope to positive slope. So it's going to be at x equals -1 and x equals 1. Relative max happens where your slopes change from positive to negative, which never happens because we have an undefined function right here. So this is never, because if we would switch from positive to negative, the slope itself is undefined, and our function itself was undefined because f of 0 is undefined. Every single time that I try and do the relative mins and maxes based off of one of these charts, I always draw out a little minimum and a little maximum to remind myself whether it's changing from negative to positive or positive to negative. So do not feel bad if you have to draw those out just to get yourself that reminder.